So in the next few problems, we're going to be dealing with compositions of functions. Now in the first one, f of x is 2x, g of x is x squared, and we want to find f of g of x. What that means is we're putting g of x as the input into f. So what we're actually trying to find is f of, and I'm going to just replace g of x with what it is, x squared. Now f of x is 2x, so that means I'm replacing every x with an x squared. So I have 2 times x squared. And there's my composition. So really pay attention to what's going in as the input. Okay. Next one, we have 3 tables, and we have to find some values based on the fact that h of x is f of g of x. And the first value we got to find is x. Well, x is going to be equal to h of 2 equals x. Let's make a note of that. Well, that's f of g of 2 because h of x is f of g of x. G of 2 is 1. So we're looking for f of 1. F of 1 is 3. And so that one's pretty straightforward. You just got to follow your progression through the composition. The next couple get a little trickier. For instance, now we have to find y here. So what we know about y is that g of 4 equals y. So let's make a note of that. G of 4 equals y. Okay, well, where does that 4 input come from? Well, that's x, and it goes into g first. So that means we're interested in what h of 4 is equal to. Because h of 4 is f of g of 4, and that is equal to 5. Alright, that's just following our composition. That's all we're doing here. We know that g of 4 equals y, so I'm actually just going to substitute that in. So f of y equals 5. So what's the input to f that gives an output of 5? Well, f gives an output of 5 when its input is 2. So we get that y equals 2. Okay, so we're working backwards in this case. Lastly, we got to find the value of z here. We see that that's when the input to f is 3. So I'm going to show you how we can reason without even writing anything down. Alright, in order to be putting 3 into f, that means we must be getting 3 from g. In order to be getting 3 from g, we need to be putting 1 in initially. That means we're starting at 1, which takes us to 3. 3 takes us to z, and our ending point should be 4. Now I'm going to go through that again because I realized that was a little quick. But what we know is the way this works is we put in x into g, which goes to f, which gives us some y. And basically, this is encompassed by h. So now let's see what our steps are. Okay, well, the last step is to go into f. So that means to go from g to f, our final thing had to be z, because that's what we're getting out at the end. To get to what we're putting into f is 3. So what needed to be put into g in order to get 3? Well, that was 1. So 1 to 3 to z is kind of our two-step process. Well, then we're going to use what starting at 1 should end at. We know that h of 1 has to be 4. So if we start at 1, so this is our x here. If we start at 1, we need to end up at 4 because that's given by our composition here. So that's a couple different ways of thinking about those. They all come from the composition though. So we're just working backwards in the second two.